class. In this lecture we will see what are the different law of thermodynamics. So basically in the thermodynamics, at the very beginning of the lecture of mechanics of thermal system, I told you there are various laws are present in order to govern the various processes and the um, cycle in order to extract a work or in order to develop a power. So there are number of laws are present in case of the thermodynamics. So here we had shown you the different laws which are exist, or which are the basic governing laws which are exist in law of thermodynamics. So it start from the zeroth law. Okay, after the zeroth law there is a first law of thermodynamics, after that second law of thermodynamics, and after that a third law of thermodynamics. So the zeroth law of thermodynamics is very simple. It tells about our flow, it tells about the nature of flow of heat energy, or it will tell about the thermal equilibrium. Okay, so in simple, if I tell you, then it tell you, if in simple word I have to tell you, then it is nothing but uh, nature of the heat energy it shows with respect to the temperature. Okay, after that the first law of thermodynamics talks about the energy balance. Okay, it's talk about the energy balance, talks about the energy balance. Okay, uh, as per this law the total energy of the universe is remains same. Okay, it won't be destroyed, or it won't be created. Okay, but there are some disadvantage, or the limitation, not disadvantage, there are some limitation of first law of thermodynamics is present after the development of that law also. So to overcome or to clarify those limitation, a second law of thermodynamics is generated. The second law of thermodynamics basically covers all the limitation is present in case of the first law of thermodynamics. So the second law of thermodynamics having basically two statements. One is the Clausius statement, and then is the Kelvin statement. Okay, so two different statements here present in case of the second law of thermodynamics, which is respect to the Kelvin statement is respect to the heat engine who develop a work output. Okay, who offer us a work by consuming some amount of heat energy or the chemical energy. And another, that is Clausius statement describes a heat pump, or we can say refrigerator, who demands a work output. Okay, who demands a work and give you a electricity or some other kind of work, but initially it consumes a works from you. Okay, so power offering what consuming device about we're supposed to talk in case of the Clausius statement. Okay, after that third law of thermodynamics will come into the picture. The third law of thermodynamics is talk about what is the nature of the system. Okay, at absolute zero temperature, or in simple word it's says that absolute zero temperature is not achievable. Okay, so it talks about the change in entropy at absolute zero temperature. So those are the laws which supposed to have in case of the thermodynamics, as in case of the our laws of motion, that is first law of motion, second law of motion, and the third law of motion. So similarly in case of the thermodynamics also we have those four law of thermodynamics, which we supposed to see one by one. So first of all we will start with the zeroth law of thermodynamics. So this is a statement of zeroth law of thermodynamics. Okay, if two bodies are separately in thermal equilibrium with a third body, then they must be in thermal equilibrium with each other. What he said, if two bodies are separately in thermal equilibrium with a third body, then they must be in thermal equilibrium. So in the terms of the explanation, we can say if A in thermal equilibrium with B. Okay, if A is in thermal equilibrium with B, and B is thermal equilibrium with C. Okay, C will be in thermal equilibrium with A. Or in another way we can say, if A is thermally equivalent with C and B also thermally equivalent with C, okay, then A and B both are also thermally equivalent with C, and they are thermal equilibrium with each other. Now, what is a thermal equilibrium? In the various in the lecture of heat energy and work output, okay, whenever we saw that term like work and heat energy, in that time I told you a heat energy is boundary phenomena. Until and unless there is a temperature difference in between system and surrounding, or two systems which sharing a same common boundary, okay, until and unless if there is a no any finite temperature difference, okay, in between two systems or system and surrounding, the heat energy will not cross the boundary. Okay, if it cross the bound and whatever the heat energy absorbed by any system, okay, till the temperature difference is there, okay, that heat energy is stored in the form of internal energy. Okay, so here you can see system A, system B and system C are sharing common boundary at this contact point. Okay, here A is having contact with C, B is having contact with C, so A, C, B, okay, A and B, system A and B are making contact with C with we can say sharing a boundary, and suppose A having temperature T1, B having temperature T2 and C having temperature T3. So till there is a temperature difference in between those three body, heat energy will share among themselves till temperature of all those three will not be same. And as soon as temperature of all those three become a same, at that time that all those three can be called as a, it is in a thermally equilibrium condition. Okay, as soon as the temperature of all bodies A, B and C become same, at that time we can say there is a no heat energy flow take place across the systems, these two systems A to C is there is no heat energy exchange, C to B is there is no heat exchange, A to B there is no heat exchange. Okay, so in that time we can say it is a thermally equilibrium state. Okay, so same thing we are due to that thing only we supposed to it is possible to check the temperature of any hot substance or any cold substance by using thermometer. So here in example I shown you, there is a some kind of liquid present inside this beaker. Okay, this liquid can be termed as a system A. Okay, after that I poured one thermometer in that. The thermometer is made by glass. Okay, and it is filled by mercury. Okay, so mercury can be called as a term as a system C, and the glass of this thermometer can be called as a system B. Okay, so whenever I pour a thermometer into this jar, I come into the or I supposed to notice the thermometer mercury present inside the thermometer are rising. Okay, rising with respect to the scale, and after some time it will stop at particular level, and after that it won't change. So how it is possible? Because thermometer glass and the mercury present inside the thermometer are having less temperature as compared to this liquid, that is A. So until and unless there is a temperature difference in between B, C system and A, all the heat energy get start to transfer, not means heat energy start to what we can say transfer from one boundary or from one system to another system, that is it will transfer to C and transfer to B from system A, and it will go on transferring till there is no any thermal equilibrium. So as soon as temperature of all those three become same, thermal equilibrium will be achieved. So the zeroth law of thermodynamics says that if the body are separately in thermal equilibrium with a third body, if two bodies are separately in thermal equilibrium with third body, then they must be thermal equilibrium with each other. So here glass and mercury are thermally equilibrium with liquid, then mercury and glass also in thermally equilibrium with each other. In that sense, all those three systems are has a thermal equilibrium with each other. So they in between them no heat exchange will take place as soon as finite temperature difference becomes zero or it becomes negligible. Okay, so this is our zeroth law of thermodynamics. So here in case of those system also we can say A is the temperature of A equal to C and temperature of B equal to C. That time temperature A and B is also same, because A and B are not having direct contact with each other, but it has a contact through C, via C. So if C have same temperature as B and A have same temperature as C, then A and B also have same temperature. So all those three bodies are having a thermal equilibrium, and we know the temperature heat energy is uh, govern or it is having a motion due to the temperature difference. Whenever temperature difference is there, that time only the heat energy transformation come into the picture. So I hope you have understand the zeroth law of thermodynamics. If you feel any difficulty, do comment in our comment section. Thank you.